Morning, everybody. Today we're going to go over the law of sines and two specific cases. Tomorrow we'll go over the third case, which we'll get into more tomorrow. But law of sines is a nice way to solve for a triangle. And if you remember, solving a triangle just means like filling out all the unknown information. So the three angles, three sides would be a solved triangle. But law of sines helps you do this even without right triangles. So it's a super helpful tool to use. There's also law of cosines, which we'll get into more a couple days from now. But there are three cases of law of sines. There's angle side angle, angle side, and side angle. And this is the case that we'll talk about more tomorrow. There's just more things to think about as you do this. But if you have a case where you're given angle side angle, if you're given this angle, this side, and this angle, angle side angle, you can use law of sines to find the other three missing pieces of information. So this angle and these two sides. Or if you're given angle side, you can do the same thing. So angle side would give you, you could use law of sines as well to find the other three pieces of information. Basically, when you're given two angles, you're good to go. Where if you're only given one angle, you have less to work with. But we'll get into the ambiguous case tomorrow. So the key here is make sure you're lining things up correctly. So also you need to find the pair that you're given. So are you given a pair of the angle and the side that goes together? In this case, that pair is B and not B. Bad start. That 40 and 4. So we're going to take sine of 40 over 4, and now we're going to set it equal to one of the other pairs. Right now we have the 60 degrees, so let's do that one. And B. And you just need to solve for B. So solving for B, I'm going to multiply by B, divide by 40, or sine of 40, so I have this so far. And another side note, remember that side lengths and angles match up. So the order in which from least to greatest of the angles should match up with their respective side. So 60 is bigger than 40, B should be bigger than 4. It's always something that you want to look into when you're going through these. And I already typed this in my calculator, but it should be about 5.39, which again is bigger than 4, so it looks like we at least passed that test. Alright, this is gamma, so gamma is going to be whatever 180 minus 60 minus 40 is, which in this case is 80. Right, 180 minus 100. So with that, we can figure out the others, and you could use B, but I wouldn't, just because we approximated that, and you're either going to be using a gross decimal or you're going to be using this less gross decimal. But you're going to set it up the same. I try to use the given angles, given sides, that way it stays nice, but sometimes you really can't avoid it. But we're going sine of 80, and we're looking for C. Again, solving for this, we're going to multiply by C, divide by 40, sine of 40, and 80, sine of 80 degrees is the biggest angle in between the three, so the C should be the biggest side. Again, always checking to make sure things are in order. Oh, what did I do there? which is about 6.13. So again, should be the biggest side. It is 6.13, 5.39, and 4 should be in order from least, or in that case, greatest to least. Yeah, so that's always a good check to have. If it doesn't match up, then you know you're wrong. From here, I don't really have a great way of checking to see if it's right or wrong other than plugging it back into Law of Signs and seeing that it checks out. But usually if you have them in the correct order, that's a good sign. All right, the difficulty here, oh, by the way, this was angle, angle, side. So this is the unambiguous case, so that this will always work. You don't have to do anything special with it. Just have to use the law of signs. Here, we'll draw it first, but we have alpha, which is 35, beta, which is 15. I'll put beta out here, alpha out here. 35, 15. This is going to be chi, or key. And we're given C, which is opposite to chi. And alpha should be opposite to A. Beta should be opposite to B. It does matter. Make sure you're not just putting A, B, C anywhere you want. Make sure they're opposite to the correct angle. That'll definitely be important within MyOpenMath. Just make sure that you're following the rules of the Greek letters for angles and sides. You can first we have angle, side, angle. So again, unambiguous, which just means that we don't have to think about it. We just have to use law of signs and, or I guess minimal thinking compared to tomorrow's lesson. All right, sine of 35. First, we should figure out, we're not given any pair, but we can figure out this angle pretty quickly. So this is our first move that we have to make. 15 plus 35 is 50. If we subtract that from 180, we get 130. So now we have a pair, and we'll use that. So sine of 130 over 5 is equal to, pick one, doesn't matter from here, sine of 35 over A. Solving for A, you should get this, which is about 3.74. So smaller than 5, 35 is smaller than 130. Don't worry too much about how close they are. That's okay. Like 130 is pretty close, or it's not very close to 35 degrees. But 3.74 feels really close to 5. All right, repeating the process this time with sine of 15 and B. So sine 130. Again, solving for B. We have this. And that means that B is about 1.69. Alright, so again, it's in order from least to greatest according to the angles as well as the sides. Another thing, remember that with triangles, if you add up any two sides, these should be lowercase, but if you add up any two sides, they need to be greater than the third. So one thing to check is 1.69 plus 3.74. That should be bigger than 5. It is, so another good sign that we're on the right track. All right, story problem time. To measure the height of a mountain, of a mountain, a surveyor takes two sightings of a peak at a distance of 900 meters apart on a direct line of the mountain. See figure below. The first observation results in an angle of elevation of 47 degrees. So this one right here. Whereas the second results in an angle of elevation of 35 degrees. If the transit is 2 meters high, what is the height of the mountain? That 2 meters is just going to come at the very end. We're going to have to add 2 to the height of B. But that's going to be unimportant for now. Just the very last step is going to be adding 2. So to get this, we just need to figure out the value of B, but we don't have enough information within this triangle to get there. We have to start off with this. There's a few routes you can take. You can go for C. You can go for I would assume that to be B, but we already used B, so I'm going to call that X. So we can go for C or we can go for X. I would personally go for X just because that is also a part of the next triangle. So once we get the hypotenuse of that smaller triangle, we should be able to find B. So that seems the fastest route. So that means that we need to figure out these angles in the small triangle on the left. To do this, we need to think about this triangle as well. 180 degrees makes a straight line. We've used up 47 of those degrees to get this angle. So 180 minus 47 is going to be lambda. No, it's gamma. Which should be 133. Okay. Once we have that, we can use these two angles to get to alpha. So alpha, once you do 180 minus those two angles, should be 12. And there are other ways to get to that being 12. If you remember back to geometry, these two angles should add up to 47. So we could have done 47 minus 35 to get to 12, but however you get there, alpha needs to be 12. So once we have that, we have a pair of angle and side. So we can use law of sine now. Also, we have angle side angle, so we could use it again. Or angle side, so we have both cases that we're allowed to use. Sine of 12 over 900 is going to be sine of 35 over x. Once we solve for x, we should get that x is 900 sine 35 over sine of 12. And if this is not important, we don't need to know this yet. But if you wanted to check that, I did not come up with an approximation. So not important at all because I didn't come up with an approximation. But if you wanted to, you could type that in and figure out what that length is. But it doesn't help you solve the problem. It might just help you figure out if B makes sense. But we're going to use this. I'm just going to use x for the sake, but sine of 47. Now I'm going back to this triangle. Sine of 47 is across from B. That should equal sine of 90 over x. Right angle across from x. Sine of 90 is 1, so we don't have to do too much here. Sine of 47 over B equals 1 over x. Remember, we know x. We're not actually solving for that. We're solving for B. So I'm going to multiply by B, multiply by x. B is equal to x times sine 47. We know what x is. It is 900 sine 35 over sine 12. If you multiply that by sine of 47, you get about 1815.86. That's a 5. So this is equal to b, or about. The height of the mountain is b plus 2. So h is about 1817.86. Okay. Kind of cool. You can measure the height of something without even getting close to it. And we don't even have to know how far we are from the mountain to do that. It makes it hard when you're trying to measure to the peak of the mountain, when you can't know directly how far you are laterally from it. So it just creates another issue, but you could just back yourself up, get 2 different angles, and you're good to go. But that is all for today. Tomorrow we're going to be talking about the ambiguous case, which is a whole nother issue, but until next time.